Okay, so we have a model with three predictors in it, the percentage change in the gray matter annual percentage change. We have the indicator variable that separates the Alzheimer's from non-Alzheimer's patients. And then we have the interaction term. And when I wrote this, I probably should have used a multiplication sign in between them just to really drive it home that this is an interaction term. So we can look at the model here, but the question we might run into, especially looking and seeing that neither of these p-values are actually significant, do we want to go through that trouble of having an indicator variable and having this variable interaction term here? It would be a much simpler model if we just had the percent change in brain mass, but we want to see how much added predictive power these two as a package are providing. If we just wanted to see an individual one, we could look at what's going on here in the p-test, but we want to see as a package how much are they adding to it. So we go here, make sure your method is set to enter and that you have the full model here, so all three. And then if you scroll down, we have this option of creating a null model. And this would be what the full model is getting compared to. So we want to compare the full model to the model that just has that annual percent change in gray matter. And if we look at this, we can see that the r-squared does go up, even the adjusted r-squared. So the r-squared is always going to stay the same or go up, but the adjusted r-squared goes up with the full model. So the 0 would just have the gray matter. Model 1 would have the gray matter, the interaction term, and the indicator variable. We can see the full output here. You could use this output with the formula in the book on page 129. Again, just remembering that model is represented by the word regression, and this would be the full, this would be the null hypothesis model. And if you did that, you'd go through the calculations and you'd get an F statistic of 1.342, which you could then look up on a distribution and find out that it's not significant. But there is a way to do that using JASP itself. If we scroll down, there's an option to click r-squared change. What this means is not only do we have the r-squared of the null model and the r-squared of the full model, but we can see the actual effect size of adding these two terms to the null model. So just by clicking that, if I go and look at my output, notice up here in the model summary, not only do I have these original terms, but I also have r-squared change. So the first r-squared change really is just going from no predictors whatsoever to having that first gray matter in there. So this r-squared change is going to be the same as the original. That's why the 0.298 is the same as this. It's going from no predictors whatsoever to having that one predictor. But this here is really the key. This is what's the impact of going from the model with just the gray matter, just the APC, to the one that has all three predictors, has the interaction and indicator term. And so this is the r-squared we get. And we can even see what the F, there's that 1.342, the F value that you would have gotten if you had plugged in all those numbers into the formula that was given in our book. It tells you the degrees of freedom of the particular F distribution we're looking at, and it even gives you the p-value of that change. So p-value 0.274. What this tells us is that, yeah, maybe we get a tiny little bit of extra predictive power by adding in the interaction and indicator, but it's not a statistically significant amount, and the fact that it makes the model much more complicated would probably leave us concluding that we should just go with the original model that only has APC in it and just do a single regression line, which would end up being a simple linear regression actually. Or potentially we could look for other things that explain that outcome, but based on what we see here, whether or not the patient has Alzheimer's is not a big enough differentiator that we should really include it in the model.